1A, if I asked you to solve this, what would we have to do? So we could take out an x, that leaves us with x minus 7 equals 0. So then we set each to 0. So we get x equals 0 and positive 7. Second one, what would we do to solve that? So this is factored into x plus 15, x minus 2. Pretend I had a equals 0 up here. Okay. Then we have to divide by 10. So 5 over 10 reduces to 3 over 2. 2 over 5 is, or 2 over 10 is 1 over 5. So we get negative 3 halves, positive 1/3. Are we okay with those? Let's look at this. So what do I have to do here? Negative 6 minus 18i minus 8i minus 24i squared. So 26i. Negative 24i squared would turn into and then we add like terms. Remember, if it has an I expect a plus bi form for the final answer. So we get 18 minus 26i. Last one here. What do I need to do?
Make the minus a plus
Mhm.
change the sign.
Good. Becomes plus, we run that negative through. So now we're just combining like terms. We're not multiplying. There's still an addition sign, so just add your like terms. So negative 1 plus negative 6 is negative 7. Negative 4i plus negative 7i is negative 11i. Are those okay with everybody? Massive class. How are you?
Tiny class.
I'm missing one.
Oh.
Yes, that
Well,
makes all the difference.
you got the biggest troublemaker in school over there, and I tell him
I know.
rocks that I'm gonna steal when he gets home.
Okay, so now let's talk about some of the word problems. Let's see. Do you guys trust me to make up a good problem? How about, let's open our book, page 171. We're going to try a couple of these. Let's take a look at number 11. So if we look at this problem, says a chemist wishes to strengthen a mixture that is 10% alcohol to one that is 30% alcohol. How much pure alcohol should be added to 12 liters of the 10% mixture? So, what do we need to do here? Right, make our chart. And what formula do we put across the top?
Amount.
Times
Times
concentration.
amount pure or something.
So you have to have labels on these tables. I don't just want like a blank table and numbers in it. Defining your variables is more than just placing it in a table. I have to know what it's standing for. So make sure you are putting those labels. As far as the rows, we could call them whatever we wanted, as long as it made sense. We have one that's 10%, and we want 30%. We could call them first, second, and total. You could use the percents here, whatever you would like. So then it says we have a mixture that is 10% alcohol. So the concentration of that would be, and we always did, right. And the 30%, where does that go?
A mixture.
Okay. How much pure alcohol? So the other one is pure, so what would the concentration be? The amount is X because it said how much, and the concentration?
Would be 100% pure.
So 100% would be a 1. Okay. Remember we talked about with these percents, the final one has to fall in between the two you're mixing, so double check. I mixed the highest and lowest, I should get something in the middle, so 10 and 100, that gives me 30, that seems reasonable. So how much pure alcohol should be added to 12 liters of the 10%? So we had 12 on this one. So what is my total? What would be the total amount?
Just 12 plus X, right?
Mm-hmm. And then to get that last column, remember we just saw the formula. It said amount times concentration, so we multiply. So we're doing the 0.1 times 12. 1 times X. 0.3 times the 12 plus X. And you could go ahead and multiply those. I'm just writing it out to show you what I'm doing. And once we get to that point, our equation should write itself. You always add the first two to equal the total. So 0.1 times 12, 1.2 plus X equals side, so if I subtract over my 0.3x, subtract over the 1.2, divide, it is not going to come out perfect. So different ways you can say, 3.4. You could say 24 over 7. You could say that would be 3 and 3/7. I don't really care, but what is the important thing that we have to do to finish this?
Right, second.
Write a sentence. So the question was how much pure alcohol? would be needed. Maybe we might just set up one of each of the other types and not actually solve it all the way. So we did the concentration problems. We did distance problems. So if I said, I don't know. Problem with these, it's easy to make up one that doesn't work out to be very nice at all. Okay, David gets to work in 20 minutes when he drives his car. Riding his bike the same route, it takes him 45 minutes. His average driving speed is 4.5 miles per hour greater than his average speed on the bike. How far does he travel to work? What should I do here? Anytime we're doing these problems. When we make our table, what formula are we talking about in this instance? Remember on the distance problems? It was rate times time equals distance. Okay, so we have his car and his bike. The only speed that I gave you is in miles per hour. So if my speed is miles per hour, what does time have to be measured in? Hours. Okay, so it said it takes him 20 minutes to drive his car. So what time would I put for the car? 20 minutes is 1/3 of an hour, 20 over 60, 1 over 3. Riding the bike takes 45 minutes. Sorry, this is number, if you want to look, page 99, number 21. So riding the bike is 45 minutes. So what would that be in hours? 3/4. 45 over 60. Okay. His average driving speed is 4.5 miles per hour, greater than the average speed on the bike. So do we know how fast he goes on the bike? No. But in the car, he's 4.5 greater. So what would it be?
X plus.
Then rate times time equals distance. And what would be true about those distances? They would be equal. So I'm not going to finish solving it for the sake of time, but to finish you would just set those equal and solve an answer in a sentence. Okay, so 2 formulas we need to know. Amount times concentration equals amount pure. Rate times time equals distance. The only other ones we had were really ones that involved like figures. We did some with like perimeters and things. In that scenario, remember we would draw a rectangle or square, whatever, and label our sides. What does perimeter mean if I talk about that?
And the both sides.
And both sides, and most of those involve perimeter.